Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list published on July 10th, 2025. So, just yesterday, this paper introduces a framework that boosts the performance of the Claude 4.0 Sonnet model by a remarkable 31.1% on the VLM's R-blind mini benchmark. The paper is titled PyVision, Agentic Vision with Dynamic Tooling, and the core idea here is really what's so powerful. Instead of relying on a fixed set of tools, this approach allows models to autonomously generate and refine their own Python tools to solve visual problems. Also, the authors shared the official implementation on GitHub. If you're looking to try this out, you'll find the complete source code, prompt templates, and detailed instructions for running PyVision yourself. They've included everything you need to get started, from setting up the environment to configuring your API keys. To really see this in action, the authors provide a great visual example. The figure shows a visual puzzle, a twist on the famous Ebbinghaus illusion. Now, a standard multimodal large language model, or MLLM, which is a model that understands both text and images, gets it wrong. It sees the pattern and incorrectly recalls the classic illusions answer, but with PyVision, the model doesn't just guess. It writes and runs Python code to isolate the orange circles, calculates their exact pixel area, and correctly concludes that the right circle is much larger. This shows it's not just pattern matching, but actively reasoning. So, to put that powerful reasoning capability into context, this table compares PyVision with previous tool-using methods. It looks at three key features: having a dynamic workflow, which means adapting the problem-solving steps, a multi-turn framework for interactive refinement, and crucially, dynamic tool generation. That's the ability to invent new tools from scratch. Looking at the table, you can see that while a few methods have some of these features, PyVision is the only one that checks all three boxes, which is what makes it so uniquely flexible. Building on those unique features, this next diagram shows us exactly how that multi-turn framework operates. At the top, you have the multimodal large language model, which receives an input. It then generates a code block, basically a snippet of Python code, and sends it down to a safe runtime environment for execution. This environment runs the code and sends back a result, called a multimodal clue. This back and forth loop continues, with the model refining its code and gathering clues until it's confident enough to produce the final answer. Moving to the results, this table really quantifies that performance boost. It lays out the scores on 6 different benchmarks, comparing base models like GPT 4.1 and Claude 4.0 Sonnet against their PyVision enhanced versions. And the improvements, shown in green, are striking. For example, PyVision gives Claude 4.0 Sonnet a massive 31.1% lift on the VLM's R-blind mini benchmark. This shows the framework acts as a powerful amplifier, significantly enhancing the base model's own reasoning capabilities on these tough visual tasks. So to wrap things up, what we're seeing with PyVision is a fundamental shift from simply using tools to actively inventing them. Instead of being stuck with a fixed set of functions, the model creates its own custom Python tools on the fly, tailored to each specific visual puzzle. This dynamic agentic approach, where the model acts more like an independent problem solver, not only leads to those impressive performance gains, but also makes the reasoning process more flexible and transparent. It's a really exciting step toward more capable systems. That's all for this episode of the AI Research Roundup. Thanks for tuning in.